sir for about more than 12 years, I suppose. Anna, we are very proud and I'm so happy to have you amidst us for this guest lecture. And he's a very good resource person. And you can, I think Anna will also be sharing the YouTube videos where he actually motivates and it motivates the young researchers and gives basic information on all the parts of chemistry. So I'm indeed happy to invite Mohanraj Anna amidst us. And Anna, just we'll start with a prayer song or something.
Okay.
Renali, can you take over the session here?
Yes, ma'am. A very good morning to one and all present here. I extend a hearty welcome to all of you on this Thursday morning for a lecture series on photochemistry. Faith and prayer is vitamins to the souls. No man can live in health without them. To begin this session, I request Sister to sing a prayer song.
Welcome, Holy Spirit. We are in your presence. Fill me with your power. Live inside of me. Welcome, Holy Spirit. Be here with your presence. Fill me with your power. Live inside of me. You're the living water. Never drink water. Comforting and comforting. Take complete control. Welcome, Holy Spirit. We are in your presence. Fill me with your power. Live inside of me. Welcome, Holy Spirit. Be here with your presence. Fill me with your power. Live inside of me.
Thank you, Sister. It gives me an immense pleasure to introduce to you a key speaker developing researchers. So, graduated from Photochemical University, PhD, in 2005 in BSc Chemistry, and in 2007 in MSc Chemistry from Bharatiya University, Coimbatore. Sir finished his MPhil in 2009 and his PhD in 2018 in the topic Organic Chemistry from Bharatiya University. Sir has special interest in the fields of applications of organic materials, chemistry of natural products, and synthetic organic chemistry and crystal growth. Sir has guided 3 candidates through MPhil and is currently guiding 1 candidate through MPhil. Sir has many national and international publications in journals like Wiley Publications, Elsewhere Publications, WJPR, and many other journals. Sir has also been published through 2 books, namely Pneumocystis Jirovecii Pneumonia, a bioinformatics approach, Lambert Atomic Publications, and In Silico Drug Design of Piperine from Black Pepper, White Book Publications, which is an international book. Sir has carried out a research project for UGC for 2 years on the topic Cytochemical and Pharmacological Investigation of 3 Indian medicinal plants. Sir has presented 8 papers at attended 7 national-level workshops and presented 5 papers in international conferences. Sir has won 3 Best Paper Awards, the first one in 2012 in ICAM, the second one in 2014 in a DSP-sponsored national conference on the topic Advanced Development in Medicinal Chemistry and Target Drug Design, which was conducted at Konganadu College, and the third one in February 2015 in a UGC-sponsored national conference on the topic Recent Trends in Medicinal Chemistry conducted at Government Arts College. I extend to you my hearty welcome, sir. It's a great pleasure to have you amongst us today.
Thank you, ma.
Thank you, sir.
Thank you, ma. Shall I start, ma?
Yes, sir.
Okay. Respected Principal, Secretary, Head of the Department of Chemistry, and Dr. Divya, and my dear students, good morning to all. So I'm very happy. So today my lecture, Photochemistry, Chemistry of Lights. So very happy. So now I am share my PPT. So before my speech, I would like to thank Department of Chemistry, HOD Gunavadi ma'am, and other staff members, and my junior Divya. So give me a wonderful opportunity to deliver my talk, the photochemistry of and chemistry of lights. So basically the photo means photochemistry. We are talking about the photochemistry. So what is photo? Photo means light. So as a chemistry students or chemistry staff, we are know about what is photo or light, what is thermal reactions or photochemical reactions. There are the two important concept reactions. So in case of we are running some many reactions in thermally. So basically the thermal reaction is initiated by the activation of due to the molecular pollutions. So we are heating some temperatures, 100 degree, 200 degree, 250 degree, some other degrees are there. So basically the depend on the temperature, that is thermal reactions. So here we are talking about the photochemistry. Photo means light. So initiated act due to the absorption of light. Some other reactions we are involved in photochemically. Photochemically means we are simply we know that the microwave or some other light. So UV or infrared radiations, we are passed through our compound. So suddenly the compound is absorbed some energy. So these type of reactions is not dependent in temperatures, only for dependent on light or photons, right? So here we are talking about the reactions rate change with the temperature as the thermal reactions, but here the only depend of the rate change with the light intensity. So that is called as photochemistry. Just I will introduction about the photochemistry, but here we are talking about the chemistry of lights. There are the many kind of. So now I am going to introduction part. What is photochemistry? The photochemistry is light, study of the interaction of electromagnetic radiation with matter, resulting in the physical change or into the chemical reactions. That is called as photochemistry. So just you think that the study of interaction of electromagnetic radiations. So here we are talking about electromagnetic radiation. Simply we call it as a EMR. So in case of the radiation with matter, the resulting is physical change. Physical changes, temperature change or some other morphological change, some other chemical reactions. So this is called as a photochemistry. So primary process, the one molecule is excited into an electronically excited state by the absorption of photon. It can be undergoes to number of different primary process. primary process. Whenever the received our compound in light or heat, so suddenly the molecule absorbed energy. So it will be changes, the resulting is the physically changes or into the chemically changes. So these type of process, the photochemical process, are those two which is excited species of dissociated, isomerism, rearrangement, or the react with the another molecules. So some changes will be occur in these reactions. Photophysical process including the radiative transition, in which of exciting molecule emit lights in the form of fluorescence or phosphorescence. So the technical word here we are talking about the molecule emit light. Molecule or ions or atoms or molecules absorb some energy. So suddenly the molecule emit the lights form of the fluorescence or phosphorescence, that is returned to ground state. So this is for the intramolecular or non-radiative in which some or all of the energy of observed photon is ultimately converted into heat. So this is the fundamental concept. So whenever we are passed lights through some chemical compound, the chemical absorbed some energy, the electron are absorbed some energy to ground state to excited state to again the ground state. So there are the two processes will be there, that is of fluorescence and phosphorescence. There are the two processes return to ground state. So this is for the fundamental concept. There are the photochemical process of excited dissociation, isomerism, rearrangement, or react with another molecules. So this is the fundamental concept of photochemistry. Now, so let's see what is electromagnetic radiation. So as a chemistry man, we are very well. It is a Maxwell suggests that an alternative current of high frequency is capable of radiating energy in the form of the wave. So in this wave motion consists of electric and magnetic field, so which are the directed perpendicular to each other. So this is the electromagnetic radiation. The velocity of radiation is almost equal of the light. Here you see some diagram. Here the direction magnetic field, electric field. Magnetic field, the red line is called as a electric field, blue line is called as a magnetic field. Some directions is there. So whenever it is the wave motions consist of electric and magnetic field, which is directed to perpendicular each other. So this is the fundamental concept. So velocity of radiation almost equal of light. Hence it is called as a electromagnetic waves or electromagnetic radiation. This is called as a EMR. So commonly we call it as a EMR. So what is the source of? So very good example. It is the sun is the source of the electromagnetic radiation. But every minute, every seconds, the sun is exposed to the source of the electromagnetic radiation, the core of electromagnetic radiation. Every minute they are produced in from sun to earth. So we got the many kind of the EMR is we calculated here. So whenever the interaction of electromagnetic radiation with waves with matters, so there are the two possibilities there. The interaction of electromagnetic waves with matter, one is absorption is there, another is emission is there. So whatever may be the interaction of the EMR, the absorption, emission, the both are is running in every minute of the molecules. So this is energy H nu. So received to particles, so emitted or absorbed. There are the two processes there. So this is for the interaction of electromagnetic. So in the suddenly, so whatever the chemical reaction, whatever the atoms, whatever the ions, atoms, molecules or groups, so whatever the may be, so whenever you pass through the EMR electromagnetic waves, so suddenly the absorption or emission, there are two processes, so compulsory it will be run, right? Okay. So basically you see this the atom. So what are the atoms? Atoms consist of proton, neutron and electron. So there are the three important ions in the atoms. So outermost of electron and inner is proton and neutron is there. So proton, neutron is a neutral charge. Neutron is neutral charge, proton is positive charge, and electron is negative charge. So already we very well that So whenever the interaction of EMR, so the molecules of EMR, so interact with some other radiation. So radiations means EMR, UV, IR, and other microwaves, whatever radiation is observed. So suddenly the energy is observed and emission. So there are the two processes there. So some interaction with the EMR process, right? Here the electromagnetic spectrum. You see here the some spectrum is you cut here, so you take some prism point. So there are the many kind of EMR is there: gamma rays, X-rays, UV visible, IR, some other microwaves and radio frequency. So visible region only for we are seeing some object. Here the violet, blue, green, yellow, orange, red. So this is the visible region. So our vision, our eye is detected only for the some colors. So we are seeing only for the visible region. So we cannot see the X-ray, UV, gamma ray, IR and microwave and radio frequency. We cannot see because of our vision, our eye is only range for the visible region only. So another EMR radiations we cannot see. So this is the fundamental concept of the electromagnetic spectrum. So here another one point is a EMR. EMR are electromagnetic radiation observed in any atom or any particles or some other atoms or ions observed. So Planck content principle is very important. So here the some point. So this is for the one level mu is equal to 0, 1, 2, 3, 4. So some other the radiations means rotational, vibrational and translational states. There are the three states is possible: rotational, translational and vibrational, right? So here the what happened to an atoms or molecules that absorb the photons? There are the possible. So light absorbed, each quantum is taken up by the single atoms or molecules, and the whole energy of the quantum is communicated to it. Whole here is the one some important word. The single atoms or molecule and the whole energy of quantum is communicated to it. So absorbing atoms or molecule is excited. So suddenly whenever the molecule is some other energy is observed, suddenly molecule is excited. That is lifted from the its normal state of lowest energy. Lowest energy means highest stability, and then excited. So energy rich state. So ground state to excited state will be whenever the energy received. So suddenly the whole molecule or an electron is absorbed energy. The ground state to excited state will be excited. So according to Niels Bohr theory, atoms of the molecules molecular structure and atoms or molecule can exist only in the series of the discrete states of electronic level. So this is the Planck content principle. So here example of the state, ground state. Here we are talking about the ground state E0, and two excited states E1, E2 is the two excited state. One is E1 is one level and E2 is another one level, right, of the molecule. Here the two possible is there. That means the vibrational and rotational levels are not shown. Vibrational means any molecule is normally it's vibrated in ground state. So whenever the observe the light, suddenly the vibrated molecule is rotated, and rotated molecule is translated. So one energy level to another energy level. This is for the electronic excited levels, right? Here the two possibles, energy is ground state excited state. So E1 to E2 is the first level of absorption. Another B, it's a second level. It is whenever observed the light, the electron is excited, another suddenly it will be ground stated. It will be collision deactivation. There are the possible for collision deactivation. That is called as M1 is observed. So suddenly the photons are so whole of the atoms are observed in a excited state. So suddenly the ground state will become. So that is called as E2 and E1, and then it is E1 to E0. This is called as a emission. So one is observed, another one is emission. This is for the we are talking about the Planck content principle. So whenever the light observed, the each quantum is taken by of the single atoms or molecules, and the whole energy of quantum is communicated to it. So this is for the level 1, 2, 3, 4, Another one is n is equal to 1 level and n is equal to 2. N means we are the principal quantum numbers. We are talking about the Frank-Hunter principle, right? So we are talking about the principal quantum number, asymmetric quantum number, magnetic quantum number. There are the 4 types. Spin quantum number is, right? Here there are the laws governing of the absorption of light. There are the 2 important laws. One is the Lambert laws. This is law states of that the decreases of monochromatic light, which is thickness of the absorbing medium. So it's proportional to the intensity of incident light. This is called as a Lambert law. So minus di by dx alpha I. So for this is the I naught is the intensity of the incident light, I is intensity of the transmitted lights. So K is absorption of the coefficient. So this is for the Lambert law. Another one is Beer's law. So Beer's law is consists only for the only concentration. So whenever the decreasing of intensity of monochromatic light, which is thickness of the solution, is not only the proportional to the intensity of the incident light, but also to the concentration of the solution. So this is the difference, Lambert law and Beer's law. So Lambert's law only discussion of the thickness of the absorption medium is proportional to the intensity of incident light. Beer's law is for the only for his solution is to the intensity of the incident light, but also is the concentration of the C is the solution. So mathematically di minus di by dx is IC. So here which is integration of changes I is equal to I naught, E is minus E Cx. So epsilon is molecular absorption of coefficient or molecular exchange of coefficients, right? So photochemistry. So here the study of the interaction, study of the reactions are about the actions of visible or ultraviolet light. So normally the photosynthesis of our plant, so every minute the receiving some energy from sun. So visible lights or ultraviolet lights, whatever the lights received, there are the 2 processes, the carbon dioxide and water molecule and sunlight, chlorophyll. So chlorophyll is prepared the glucose. Glucose means starch. Starch prepared every minute. So this is for the food for the plant foods. So every seconds the photochemical reaction will be occurs in plants, right? Okay. Another point, the chemical reaction accompanies with the light or by the reactions of light. So A, B, there are the 2 possible. The new molecules is generated by the chemical changes. Light induce the reaction. First point, light induce the reaction. Some reaction during the chemical reaction light of emitted, that is called as a chemiluminescence. Chemiluminescence. So this is 2 process. One is a molecule is generated the chemical changes, the light induce the reaction, and some reaction during the chemical reaction light of emitted the chemiluminescence, right? So our eye, so this light, the red light is reflected to eye. So every second we are seeing some object, some other man, some other object in our opposite vision, right? So how to vision is running. So there are the 2 chemical processes. So Leven's retinol is converted into trans-retinal. So whenever the received the light from the sun, so suddenly our retinal is received light energy. The chemical is converted into Leven's retinal to trans-retinal to Leven's retinal to trans-retinal. So this process is continuously running every seconds. So these chemical photochemical reactions occurring in our eye. So that's why we are seeing any objects suddenly. So because of this is the eye vision is running for the chemical reactions, right? Photochemical reactions. So another one, effect of the photo excitation of the pi electron, pi to pi star orbital. So in case of carbon-carbon double bond is there, the pi square electronic excitation, double bond is keeps to molecule planar. So and provide the twist of carbon-carbon double bond. Whenever the carbon-carbon double bond have the 2 one weak bond, one strong bond, is one is the pi bond. So whenever the double bond is received some energy, bond is broken, it is pi star, the electronic configuration double bond broken, it's twisted and occurring the about the carbon-carbon bond. So whenever the double bond is broken and is formation of the single bond, right? So this is one type of the effect of the photo excitation of the pi electron of orbitals, right? So this is for another one interaction, the irradiating babies with the jaundice. In case of any child is affected in jaundice, in the newborn child. It causes of photochemical changes. So suddenly the cause of jaundice pigment to becomes a water soluble and to be excited. So suddenly the fluorescent light or some other lights will be passed through the body of the mild jaundice. So the jaundice compound is decomposed in the pigment is decomposed in fluorescent lights, right? So this is one type of photochemical reactions. Another one is luminescence. What is luminescence? Chemiluminescence. So chemiluminescence, there are white phosphorus glows to ignitions, air formed, the phosphorus is pentoxide is formed. So this is for the chemiluminescence. So whenever the phosphorus, oxygen and water molecule, there are the two possibilities, which H nu is some potent light is formed. So another bioluminescence, mushrooms, the emission of light is having the living organism. There are the two possible, mushrooms, insect and fishes. These are the observed for the bioluminescence. So in other luminescence are the occurring in the chemical, that is called the chemiluminescence, and bioluminescence is of living organism, right? Okay. Light, basically light is electromagnetic field vibrate the spreading in quanta. Quanta means photon. So photon, the smallest amount of light carrying the energy of photons of Einstein, right? So the formula of E is equal to h nu equal to h c by lambda. So the one particles of chemical substance can be observed only one photons from the light beam. So this is the process. This is the light. What is light? The energy of photons of Einstein law, E is equal to h nu is equal to h c by lambda. So another way, the chemical bond energy. So from the 100 to 1000 kilojoule mole minus light energy. So here the ultraviolet, visible or infrared. There are the three regions is possible. Ultraviolet region is 200 nanometer to 400 nanometer, and then visible region is 400 to 800 nanometers. Then another rest of the region is infrared region. So we can see only the visible region, the VGR line. Okay, UV and visible region is expected to induce the chemical reactions. So there are the two ultraviolet or visible lights are received some atoms or molecules. So suddenly the chemical reaction will be occur. The range is 200 to 800. 200 to 400 is ultraviolet region, and 400 to 800 is the visible region. So there are the two region is running in our chemical reaction. So law of important laws main is photochemistry observed by the can be produce the photochemical reactions, Grothus and Dropper reaction. The law of photochemistry, right? The molecule observe the single quantum of lights is becomes excited for the star and Einstein. So this is for the law of photochemistry. Mainly we are called as here. Once again, so the two laws main for the laws means Grothus law. Whenever the light fall on the substance, the fraction of light is observed and remaining the transmitted. So it is only for the observed light that can be bring about the chemical changes. So this is known as the Grothus and Dropper law, and then this law is purely qualitative, gives to no quantitatives. So relationship between the amount of the light observed and number of the molecule reached, right? So this is for important Grothus law of photochemistry, law of photochemistry, right? Okay. Another basic principles of photochemistry is the base with the following fundamentals: the photochemical energy and electronic excitation, excited state, modes of dissipation of energy, and energy transfer, quantum of efficiency. This is the main fundamental, the basic principles of the photochemistry is covered this point. The photochemical energy. What is the photochemical energy? So already I told you the chemical transformation activation energy must supply the O2 molecule. Such as energy can be provided in the two different way. The sum of the undergoes to molecules undergoes to spontaneous transformation, continuously the spontaneous transformation, and in some case of energy is supplied to increasing of temperature, the thermal condition. So as a result of molecule present in the system have the same amount of energy throughout the chemical transformation, right? So this is a two chemical photochemical reaction. The method of the present of system involving the absorption of electromagnetic radiation, visible or ultraviolet region. Already I told you such absorption of light excited individual molecule from the ground state to excited electronic state without affecting of the surrounding molecules. So selective excitation, light is excited molecule from differ from the chemistry and those of the ground state. So one can change the course of reaction, activation with the reactant by light rather than of heat, right? Another infrared region that produce the vibrationally and the rotationally excited molecule, while the light of visible and ultraviolet region has sufficient energy to cover the range of chemical bond energy, and it is able to induce the chemical changes excited the molecule higher electronic states. So in case of ultra infrared radiation, we are using some molecule. There are the two processes running. One is a vibrational or rotational excited molecule. While the UV visible light, we are using sufficient energy covered range of chemical bond energy is able to induce the chemical bond energy able to the induce the chemical changes exciting the molecule higher electronic state, right? Electronic state levels to ground state to excited state, electronic excitation. Here the bonding molecular orbital and anti-bonding molecular orbital, right? The promotion of electron from the bonding orbital to corresponding anti-bonding molecular takes place. The sigma to sigma star, pi to pi star, n to sigma, n to pi star. So ground level to excited level. So this is for the electronic excitation or electronic transition. So sigma to sigma star is higher energy level, pi to pi star, and n to pi star, n to sigma star. So these are the electronic transition in UV range, UV region, right? The molecular orbital diagram, in case of molecular orbital, CH2 double bond CH and CH double bond CH. So this is for the butane. This is for the butadiene. So pi to pi star transition occur with the psi 2 to psi 3, psi 2 to psi 3. Here psi 1, psi 2, psi 3, psi 4. Here the electronic excitation, the bonding orbital is lower ground state and the anti-bonding bonding orbital is excited psi 3 and psi 4. So right, the ground state and excited state, and again it is energy emission, that is a bonding orbital, so excited state. So this is two process of butadiene pi to pi star transition occur there, psi 2 and psi 3. So excited state modes are dissipation of energy. What is excited state? The organic molecule even number of electron to are paired in the ground state. The name is even number of electron are paired in the ground state. Now when the absorption of light is correct energy occurring, then one of the electron excited from the ground state by to excited by star. So retaining the spin to show the electronic spin, remaining the paired by the excited state. So this is called as a excited singlet state. Excited singlet state S1. Another is excited triplet state T1. So this for the spin inversion takes place, thus give rise to new excited state is two unpaired electron. So this is for the first point. It is occurring from the electronic paired electron. Electron are paired, that is called as a excited singlet. But here this is for the some case of inversion takes place, the new excited with the with the two unpaired electron. This is called as a excited triplet state. So excited singlet state is S1, excited triplet state is T1. So this is excited states for S. Here the ground state is S0 and singlet state is S1 and triplet state is T1. So bonding and anti-bonding. So whenever the molecule is received energy, UV or ultraviolet, so ground state to excited states. So pi to pi star is excited, and then singlet state is the paired electrons, two electron paired. So this is for not paired, right? The triplet state is more stable and then singlet state, because of the triplet state of electron or the unpaired. So laser interact electronic repulsion takes place. So while the singlet state of electrons are paired, causing inter-electronic repulsion and is unstable. So this is for basically the plot diagram of the electronic excitation. Ground state S0 and singlet state S1. You simply mind it. This is for the opposite for singlet state and paired, and it is triplet state is only for not paired, right? Okay. So next we are going to see about the Jablonski diagrams. So Jablonski diagram is for S0, S1, S2. So already I discussed here. S0 is the ground state, S1 is the singlet state, triplet is T1. Diagram, simple diagram. The Jablonski diagram is explained about this S0. So S0 is the ground state. The level is first the 0, 1, 2, 3, 4 first level, and then the S1 is the S1 state is 1, 2, 3 and S2 is 1, 2, 3. So here you think that it is there are the three important point is ISC inter-system crossing, ICC internal conversion, and F is fluorescence, P is the phosphorescence, R is the radiationless decay. So Jablonski diagram explained about there are the key, important point. So internal conversion, inter-system crossing. There are the two words. So whenever the atoms or molecules absorb light energy or heat energy, the atoms vibrating in ground state, so suddenly excited in S1 and S2, the energy is ground low level to higher level. The energy is S1 level, S1 2 level, or other S3 level, right? Excess energy is again to return back to collision deactivation, and the internal conversion is again the molecule is excited to ground state, so suddenly some energy is emitted here. This is for the fluorescence, H nu F fluorescence. So fluorescence, whenever is energy is cut, the fluorescence will be cut. So this is for the fundamental concept. Another way, some energy is S1, S2. Translation state is that the inter-system crossing. Another one is inter-system crossing. Some other is energy is exposed and to inter-system crossing is translational state. The time will be taken in this some inter-system crossing. The emission is fluorescence. So whenever the energy is cut, the fluorescence is not cut. It is some time will be taken is more than 20 seconds is taken more for give the energy. So some further example, we are wearing the watch in, with radium. Radium is whenever the light is cut off, so radium is glittering. So some other object is in our life is suddenly the light is cut, so suddenly is, some energy is reflected in this. That is called as the inter-system crossing. That is called as a delayed fluorescence or phosphorescence. That name is the delayed fluorescence or is a phosphorescence. So this is for the explained in Jablonski diagram. So very important point of the Jablonski diagram. So whenever the molecule is observed the photon energy, the electron excitation for S2 and S1, the molecule S1 state undergoes to one following the 4 energy degrading decay process. So this is for the first point. The undergoes to chemical reaction return to the ground state by emission by light process called as a fluorescence. So commonly the 10 to the power of minus 9 to 10 to the power of minus 6 second. So whenever the cut off the light, that the fluorescence will be cut. Another maybe is a ground state S0 to non-radiative process of which is energy excited to shuffle into vibrational modes. S1 to undergoes to inter-system crossing, that is called as a phosphorescence. This is for the fluorescence, phosphorescence. Emission of the proton from the singlet excited state to the singlet ground state or between any two energy levels which is the same spin, so is called as a fluorescence. You see here the same spin, the singlet is the same spin, that is called as a two energy levels of the same spin is called as fluorescence. Fluorescence decay rapidly after the excitation source is removed. The lifetime of the and 10 to the power minus 5 to minus 8 seconds. And then delayed fluorescence or phosphorescence. Emission between the triplet excited states and the singlet ground state is called as a phosphorescence. Or fluorescence may continue for the some time after the removing of excitation of source. So lifetime of the phosphorescence range from the 10 to minus 4 to 10 to minus 4 seconds or 20 seconds or whenever the light is cut off, again it is reflected in for phosphorescence, right? Okay. So energy transfer of photosensitization. The one step of radiation is transfer the excitation energy from the electronically excited molecules donor to the ground state of the another molecule acceptor. So as the result of the donor molecule and return to the ground state of the acceptor molecule gets to excited. The energy transfer to donor molecule should have to least of 5 kilocalorie mole minus acceptor molecules. So typically the mechanism for the triplet energy T1 transfer to describe the below. So you see here that D is a donor, A is acceptor, 1 is a singlet, T is 3 is a triplet. Here you see triplet state is T1, 3A acceptor. Here the first line you see D, the ground state S0 received some energy N pi star, the 1D is 1 state level D donor, is singlet state is S1 is possible occur. Another one 1D, the singlet state is S1 is converted to 3D and donor is triplet state is T1. Another 3D triplet state T1 is plus ground state S0 and the triplet state T1 plus to D donor ground state. So this is for the triplet state of 1 and the product will be obtained. So this is the whenever the chemical reaction is occur, so this process will be running chemical reactions. Okay, so simply we so I am here the butadiene is an acceptor molecule. So direct radiation leads to product. So what are the product is occur? The 2 or 3 via this ring is vapor. So easy for the butadiene. Butadiene is received to photon H nu, the 2 compound and 3. So there are the compound is donor. So when the butadiene is mixed with the benzophenone and the donor is and irradiated to 360 nanometer, then the butadiene undergoes photochemical changes yield the dimers of this via sensitization, which you this type of reaction is occur here, right? 4, 5 and 6 there are the chemical reaction is the photo sensitization reaction for acceptor and benzophenone of donor, right? Another one process for this type of reaction is occurring the donor benzophenone. Observe the benzophenone donor, but the reaction is take place of butadiene acceptors. Here the benzophenone donor is functioning as the console and while the butadiene is good acceptor to the kilocalorie mole minus less triplet energy of the benzophenone. So this is for the mechanism of the photochemical reactions of butadiene to benzophenone, right? This is for the S0 and S1. So intersystem crossing. So the 69 kilocalorie mole minus is energy is received, 74 kilocalorie mole is S1 until intersystem crossing is T1 is possible. So this is for T1 is 60 kilocalorie mole minus and 120 kilomole is S01. So energy transferred. Here the benzophenone energy level. This is for the 1,3 butadiene energy level. 60 kilocalorie, S1 is 120 kilocalorie. But here is 69 and 74 kilocalorie. The benzophenone 69 kilocalorie donor triplet energy transfer to 1,2 the butadiene and the 60 kilocalorie mole minus acceptor intermolecular transformation is occur. So there are the two processes of reaction is occur. So another one is intramolecular energy in the benzophenone donor and naphthalene. There are the two reactions. Irradiation of these compounds which lights about the 360 nanometers, 366 nanometer wavelength of absorption by benzophenone. Source there is the efficient transfer of the triplet excitation from the benzophenone moiety of the naphthalene moiety, right? So this is the two reactions of the intramolecular energy transfer of benzophenone donor naphthalene, right? Okay. Another energy transfer is cis-trans isomerism of 4-hexane-2. These are the chemical reactions of cis-trans isomerism for 4-hexane-2. So intramolecular energy transfer of weight loss observed to carbonyl groups. So for photoreactions, the energy transfer from the carbonyl group to carbon-carbon double bond takes place of new compound is as cis isomerism form. Trans isomer to cis isomerism. Therefore, H nu is equal to N pi star is occur. Right? So some other chemical reaction I will explain to you. So here you only in mind it. So whenever the atoms, ions or molecules are received some UV or lights or photochemical reactions, the molecule is ground state to excited state. The first is interconversional reactions, S1 level to S2 level, the observed, and suddenly it is a collision, the excess of energy is collision deactivation is returned to ground state again. So ground state to emission, that is called as a fluorescence. So whenever the light is cut off, the fluorescence is cut. Other one is intersystem crashing is whenever the energy is intersystem crashed, the translation level is going to the delayed fluorescence, the phosphorescence. So it will be whenever the light is cut off, so light is not cut off, the phosphorescence delayed fluorescence will be occur. So this is the fundamental concept is basically we are talking about. So in these type of reactions we are talking about the photochemical reactions, right? Okay. So I think I will conclude my session. So photochemistry, chemistry of light. If you have a student, I thank Nirmala College Management, the Secretary Principal and HOD of Chemistry, and Divya Madam. So give me a wonderful opportunity. I think students are listening. No more doubt. Okay, thank you.
I'd like to call upon Anamika to propose the vote of thanks for today's session.
A very good morning to all. Gratitude is the right attitude. I, Anamika, take this moment to express my gratitude on the behalf of my class, and it's my privilege to propose the vote of thanks. I thank our principal, Reverend Sister Dr. M. Helen, Vice Principal, Reverend Sister Dr. Mary Haliola, Secretary, Reverend Sister Ruby Alangara Mary. I extend my heartful thanks to our HOD ma'am, Dr. N. Gunavati and Divya ma'am, to give us this opportunity. I thank our chief speaker, Dr. V. Mohanraj, who has spared his precious time out of his heavy schedule to enlighten us. I thank all my classmates here for being patient audience. I thank last but not least the Lord Almighty to make this learning through virtual media a success. And thank you all for making this a huge success. Thank you, sir.
Thank you, ma. Thank you.